Welcome to Coach Taylor's class video, and today we're going to talk about what we call inscribed angles. Last set of notes, we talked about central angles and how if we have a central angle, which is an angle with its vertex at the center and its sides being 2 radii, that angle is going to be congruent to its arc. So now we're going to talk about inscribed angles and their arcs. And we've got an example here of our picture of an inscribed angle. An inscribed angle, our vertex is going to be on the outside of the circle, and the 2 sides of our angle are going to be chords, which means their endpoints are on either side of the circle. So let's get a few definitions out of the way so that we kind of know what we're doing and we can look at practice problems. So an inscribed angle, again, is an angle with its vertex, its vertex on the circle, and by on the circle we mean outside, with 2 sides that are chords. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So again, it's just what we were talking about. Our inscribed arc would be AC, and then our angle would be ABC. The measure of the inscribed angle is equal to, is equal to half the measure of its intercepted arc. We can actually write the word half there. So if we were to turn this into an equation, we can write it one of 2 ways. So the measure of ABC is equal to 1/2 the measure of arc AC. Or we can write it as 2 times the measure of angle ABC equals the measure of AC. So it just kind of depends on how you're looking at it, which one you use. So the next rule is that if our arc intercepts a diameter. So what that means is that our intercepted angle A or BAC, the 2 endpoints meet a diameter is what we're talking about right here. So if an inscribed angle intercepts a diameter, then it is a right angle. So that means that angle BAC becomes a right angle, and measure BAC is 90 degrees. And then our next rule is overlapping arcs. So again, I'm going to try to use this and highlight. So there's 2 ways we can look at it. We can look at angle ABD, which gives us arc AD, and its overlapping arc is ACD, whose arc is still AD. So if 2 inscribed angles intercept the same arc, then we know that the angles are congruent. And so what that tells us is the measure of ABD is going to be congruent to the measure of angle ACD. We're going to have examples of all 3 types of these problems. So here we've got an arc WY, and we know that the angle is half of arc WY. So angle X equals 1/2 of arc WY. So then if we know that WY is 62 degrees, we're going to simply divide it by 2. And so the measure of angle WXY is 31 degrees. And I would really love it if you pause this video here and convert 31 degrees into radians. So here we have angle DEF, and we're trying to find the arc DGF. So if the arc is half of the angle is going to be twice the arc. So the 2 times the measure of angle DEF is going to equal the measure of arc DGF. So that means what I can do is I can take my 113 degrees and I can simply multiply it by 2 to find the measure of my angle, which should get me 226 degrees. And again, if you can convert this to radians and just practice what we worked on yesterday in class. All right, so here we have angle PQR, and where PQR intercepts is it intercepts this diameter right here, which is going to create a right angle or a right triangle. So PQR is going to equal 90 degrees, which is simply pi over 2 in radians. Now, we've got to start applying some of these rules that we know. We notice that we have intercepted angle ABC. But what we also notice is that AB is a diameter. So if we then write our own chord, angle AC, or line AC, we now have a new angle. Let me change the colors to make this a little bit easier to see. We have angle ACB, which then intercepts a diameter, which tells me that angle ACB is 90 degrees. And so if I know that ACB is 90 degrees, I know I now have a right triangle, ABC. So I can simply go 180 minus 90 minus 47, which should get me, I believe, 43 degrees. So this angle here is 43 degrees. And so now that's going to let me solve the second half of this problem, which is we want to know the measure of angle BC. And so I've got an intercepted angle, BAC, which I know is half of arc BC. So I'm going to take my angle of 43 degrees and I'm going to multiply it by 2 to find the measure of arc BC. So 43 times 2, it's going to be a 6. It should be 146 degrees. All right. So here we're looking for angle JKL. And so we also need to know what our arc is. We either need to know the measure of angle of JKL or we need to know arc JML. I know neither of those, but what we do know is we know that all of the arcs in an entire circle are going to equal 360. So we're going to take 360, we're going to subtract 65, subtract 53, which should leave me with a 2, that became 5. So 35 minus 11 should be 24. So we know that our arc is 242 degrees. And we know our angles are half of our arcs. So 242 divided by 2 should get me 121. So 121 degrees. All right, so here's our other rule that we were looking at. So we want to know RST, so angle RST, and we want to know angle RUT. So RUT. So what we notice very quickly is that RST and RUT both intercept the same arc. They both intersect arc RT. So what we need to do is try to figure out what is the length of the measure of arc RT. So again, all of our arcs are going to add up to be 360 degrees. So we need to minus 75, minus 139, and minus 64. I'm going to bring out my calculator real quick to make this math a little bit easier on me. So 360 minus 75 minus 139 minus 64 gets us 82. So this arc is 82 degrees. So the angle of my intercepted arc is going to be half. So I'm going to take 82, divide it by 2, and I should get 41 degrees. And because both of these angles match up with the same arc, we know that they are congruent, which means they are the same. All right, and then here, we're just using our same principles and the same things we know, and we are applying algebra. So what I want you to do is I want you to go ahead and work these problems on your own, and then I want you to check them with the completed notes on Canvas. All right, so the last thing we're going to talk about is we're going to talk about inscribed quadrilaterals. So what this means is we have a quadrilateral inside our circle. And because it's inside of a circle, there's some basic rules that we automatically know. So if a quadrilateral is inscribed inside a circle, then its opposite angles are supplementary. So what that tells me is that angle D plus angle B is going to be 180 degrees. So angle D plus angle B equals 180 degrees. I really should have the measure on both of those angles. So I'm going to add them real quick. We also know that angle A plus angle C equals 180 degrees. So if we look at these two here, M and K are my opposite angles. I know they must be 180 degrees. So 180 minus 45 should be 135 degrees. And if we convert that into radians, it should be 3 pi over 4 if I'm doing my mental math correctly. And then again, 92 and angle J are going to add up to be 180. So 180 minus 92 should get me 88 degrees. That one I do not know off the top of my head, so go ahead and convert that to radians for me. All right, so now we need to combine our rules. So we're looking for the measure of angle P, which is there. We're looking for the measure of angle R, which is there. And then finally, we're looking for the measure of angle S. So angle S is going to be our easy one because S and Q are opposites. Because they're opposites, we know they equal 180 degrees. And so we're going to subtract 93, and we should get 87 degrees for angle S. Now here, we're going to have to do a little bit more work to find the rest of them. So if I look at angle QRS, or simply angle R, it's inscribed by arc P or SPQ. So that means I'm going to take arc SP, which is 90, and I'm going to add it to arc PQ. So 126 plus 90, we get 6, 9, 10, 11, 216. And I know that angle R is going to be half of 216, so I should get 108. So angle R is going to be 108 degrees. And once I know angle R, it's easy to find angle P because angle R and P need to add up to be 180 degrees. So this should be 72 degrees once we do some math. All right, and these last two problems, it's the same thing we were doing, but now we just set it up with an algebraic equation and solve for x. So I want you to solve for them on your own and then check your answers with the completed notes.